Here is an application of multiplication of vectors. Vector u and v are given. Draw the vector half of v plus half of v plus u. So that's my vector v, and this is the vector u. Now these two vectors are given to us. V is a position vector starting from origin, and it is 4, 1. And u vector is minus 2, 1, correct? Now we need to draw the vector half of v, and then we'll draw half of v plus u. Now when we say half of v, that means the direction is going to be same as that of v, right? And the magnitude will be half of it. That is what it means. So what we can do is, in this, if we draw a triangle here, so from similar triangles, that becomes half of v, correct? So as you can see from here, this vector from 0 to this place will be half of v, correct? So we can get it in a couple of ways. For example, I can write vector v as equal to 4, 1. So half of v is equals to half of 4, 1, right? That is 2.5. So I have 2.5. That is how I can make half of v, right? And it is not necessary that my vector v has to be here. It could be anywhere, right? For example, if I start from, let us say, this point, let's say we'll take a point here, right? So 2.5. So we'll go 1, 2, and half is here. So the vector joining these 2 points will be half of v, correct? Since position doesn't matter. So what matters is the magnitude and direction. The magnitude of this vector is half the magnitude of given vector v, and direction is exactly the same, correct? So that represents half of v. So that is how we can draw half of v. So basically we are scaling our vector, and half we are multiplying by half or dividing by 2. So that is the first part, right? Either we could do using Cartesian coordinates, right? Or like this, making a similar triangle, right? So those are options for us. Now the second part is we have to do half of v plus u. Vector u is given to us here. Now to do half of v plus u, what we can do is we can put this vector with tail on the head of this vector, right? And get our answer. So that's one way of doing it. So we'll translate this vector half of v so that we can place this tail, we can place this head right at the tail of u, okay? So we will do that part. So first we'll draw half of v, and then on that we can draw u. So let me redraw it. So let us say we have, so I'll use this vector u itself, and I'll draw this vector before it, right? That could be one option. So half of v is the vector 2.5. So we'll go half unit from here down. We can do 2 left, 1, 2, and half down. So that could be the starting point. So this vector from here to here is half of v, right? Plus u. So we get our resultant, and this is the resultant. So that becomes the resultant for us, half of v plus u, correct? So that's one way of doing it. The other way could be, we already have half of v here, and from this place we can place the vector u. Vector u is 2 units on the x and 1 on the y. So we'll go 1 and 2 units on the x and 1 unit on y. So we reach this place. So that becomes half of v plus u, correct? So this is vector u for us. This is half of v. So we have vector u. This one is half v, and therefore that represents half of v plus u, right? So there are so many ways to do it. One, we could translate this vector so that we could put head on the tail of vector u, right? Or we could place the tail of u on the head of v and make a triangle to get half of v plus half of u, right? We can also do using Cartesian coordinates. So half of v plus half of u will be, we already have this as 2.5 plus vector u is what for us? Let's write on what vector u is. So vector u can be defined as, let me define it here. Vector u is equals to minus 2 and 1 unit, right? So we can do minus 2 and 1. So we get, when we add them up, we get 0 and 1.5, 1.5. So that is the end result. You can see 0, that means along the x-axis we are not moving, it's a vertical line, and 1.5, that is the result. So either way we get the same result. Here also when we translate it, this is half and 1, 1.5. So we got the same result. So here's a quick check on it. Now representing these vectors on the grid give you a visual idea, right? And doing like this give you algebraic solution. So we have both geometric and algebraic solutions for here to understand. I hope you really appreciate it. Thanks and all the best.